So let's see how to handle this. To start off, a square root of like 9, we know that's equal to 3. Well, it turns out that every radical has a little number that goes right there called the index of the radical. And the index of a square root is 2. That's why when we look for the square root of something like 9, we say, I'm looking for groups of 2 things that are the same, that are multiplied together. Hey, there's a group of 2, and the answer is 3. So by the same token, if I have something like the third root, commonly referred to as the cube root of, we'll say 4 times 4 times 4, then I could say, I'm looking for groups of 3. There's a group of 3. So my answer is 4. And of course, you could check that on your calculator, see if you do get a 4. So that is, kind of where we're headed with this. So this first one, I can factor 32 down to, let's see, that's 4 times 8. And then 4 is 2 times 2. 8 is 3 2's multiplied together. Okay, so I've got that. Hey, guess what? We're looking for groups of 5. And I've got 5 things that are the same. But it's not supposed to multiply to 32. It's supposed to multiply to negative 32. So watch this. If I slap a negative sign on each one of these, that still multiplies to negative 32. Okay, because there's an odd number of negatives multiplied together, therefore the whole thing's negative. So so if I have negative 2 times negative 2 times negative 2, negative 2, negative 2, then I can say, hey, I'm looking for 5 of a kind. I see 5 things that are the same. So I can pull that out, and because I grabbed everything out of the radical, there's nothing left over, so the final answer is just negative 2. Okay. Now, by the same token, this guy here, I can say, all right, let's break 81 down. Well, 81 is 9 times 9. Each of those 9s is 3 times 3. Okay. Now, what's inside of the radical, called the radicand, 81, is a positive number. Okay, so that's cool. So I don't need to worry about negatives or anything. I can just say, well, that's negative the 4th root of 3 to the 4th power. So, hey, look, there's 4 things right there. So 4 3's makes a single set. And now this minus sign that was out front, it never does anything. It just stays there. And the answer is negative 3. And that's how it's done. So a couple of important things. First off, if there's something outside the radical, it's not affecting what's inside the radical. Second, if you have an odd root, then you can handle negatives. Now, if this was something like a 4 right here, we wouldn't be able to work it because it's negative, because it's an even index, an even root for a negative number, and that just wouldn't work. Okay, but odd indices, odd roots, yeah, they can handle negative numbers all day long. Okay, let's see how to check this one on the calculator. So 5th root of negative 32. So I'm going to quit to the main screen, and I'm going to go 5, math, and then notice option 5 here is the 5th root. So I'll pick option 5, and then just type in negative 32, and okay, yeah, I really do need to erase, don't I? Okay, and it's negative 2. It actually works. Okay. And then the other one was negative the 4th root, so 4 math 5 of 81. Whoa, that gave us a third. I thought we were supposed to get -3. What the heck? Here's the problem. Notice the negative is in the index with the 4 there, but that is not where it's supposed to be. So I need to write it like this, and negative, and then let's do parentheses to kind of separate the negative sign from the 4, and then math 5 was 81. And I'll hit the right arrow to get out of the radical, and then I close off the parentheses. And now this means exactly what I meant, and I get that -3, or the opposite of the 4th root of 81. Now on this one, we got a fraction. Well, guess what? Not a big deal. You can just say 4th root of the top, 4th root of the bottom. Okay. And 16, when you factor it down, it's 2 to the 4th. And when you factor down 625, it's 5 to the 4th. So we're looking for groups of 4. And hey, here's 4 2s right there. So that turns into 2. And hey, there's 4 5s right there. That turns into 5. And it's just 2/5, or 40%, or 0.4. And that's it. So just hit the top and the bottom with the radical separately if you want. All right, now we do it again, except now there's variables, which isn't a big deal, because the variables are the easier part, because it shows what the exponent is already. So that's kind of nice. So 16 is 2 to the 4th. So I've got a group, one group of 2s and one group of V's, and I'm done. And that's it. Let's try another. All righty, once again, it's 4th roots. We're looking for group size 4. So I could factor 256 down and get 2 to the 8th. And then I could get W to the 4th 6 times, I guess. Was that 4? There, and that represents 24 W's. And then I could say, well, I'm looking for groups of size 4. Hey, I've got 8 2s here, so that's 2 groups. Okay, or I can write 2 to the 2nd power. That's 2 groups of 2s. And I've got 1, 2, 3, 4, 5, 6 groups of W's. So 4 W to the 6th. That would be one way I could do it. There are other ways to factor these guys down, but you know, that works just fine. All right, so here we go, the domain of the function. Domain is all the numbers you're allowed to plug in for x. So I think we can all agree that it doesn't work so good to do square root of a negative number. So whatever's inside the radical needs to be not negative. It needs to be 0 or positive. So let's just write that down. Whatever's inside the radical must be at least 0. And then if I divide by -1 to get x by itself, I get that. That is the domain. The domain is the set of all numbers you're allowed to plug in for x. So the number you plug in can be anything that's less than or equal to 0. It can be 0 or a negative number. Let's double check that on the calculator. So to do that, I'm going to plug in the original function. And I know it's messy, but I like that one time. Okay, so 2nd square root, -x, right arrow to get out of the radical, and then -5. Okay, if I go take a look at the table, second graph, I can say, well, when x is 1, 2, 3, 4 up to 11, it doesn't work. Apparently, these guys are not in the domain. Well, that's consistent with what we saw right here. Okay, apparently only 0 and negative numbers work. Let's check it out. I plug in 0, it works. I get an answer, -5. Wow, would you look at that? Math is right. Math is good. Okay, so let's just do one more of those. So once again, whatever's inside the radical whatever is inside the radical, which is that, has to be at least 0. Has to be greater than or equal to 0. So if I subtract 36 and then divide by -6, whoops, dividing by negative changes the direction of the inequality. I get that. So that will be the domain of the function. Oh, and it says do it in interval notation. I missed that before. All right, so that would be -infinity to 6. And because of the or equal sign, we're going to include the endpoint in the solution set using brackets. And so that would be how to write it in interval notation. And you could plug in the function, and you should plug it into your calculator, go to the table, see how it looks. Okay, this thing says 6 on down works, but nothing else. So you know what? I'm going to check that on the calculator because I feel like it. So -6x plus 36. 6x plus 36. And then I think that was it, wasn't it? Let me just double check. Okay. So if I go to the table, hey, look at that. Everything that I see, all those numbers in black, all those X numbers, they are all in the domain because they give me an answer. But as soon as I get above 6, the deal's off. 7's not in the domain, nor 8, nor 9. Only 6 and smaller is in the domain. And you know what? You can see that on the graph if you want. You could graph the function. Whoops, I don't want the shading. Sorry about that. Let's see. All right, now let's do it. Notice the graph only uses X values from 6 and smaller. It doesn't go over here where using larger X values, only 6 and smaller, just like we said. So you can explore this using the graph and the table to help you confirm what you're doing. Now, to find the domain of a higher root function, I'll just tell you right now. Remember a moment ago when we saw that if it's an odd root, it can handle negatives? Okay, so that means that there's not going to be any restrictions. It's just going to be -infinity to infinity anytime there's an odd root. Just that easy. Now, an even root, the deal's off. You can't do that. It turns out it's just like a square root, because square root's also an even root, second root. So for that one, we would say what we did a moment ago. Whatever's inside must be at least 0. So add 8 to both sides and divide by 4. And that'll be the domain of g of x. And that's how we do it.